All right, welcome to geometry. This will be our first lesson. Today's lesson is the essentials of geometry. We are going to do a lot of definitions at the beginning because we're going to focus on the idea of points, lines, planes, and make sure that we understand the differences between all those things. Okay, so let's just go ahead and dive right in. All right, a point. Things that you have to understand is how we write them and what they look like. So whenever you see, a big old dot and a letter next to it, that's going to represent a point. Okay, so in this example, I got a point A. Over here, you're going to see a point X, you see a point M, so on and so forth. Okay, points have no depth and no length. Okay, they are just simply a dot on the page. If you think in terms of a map, if you were to find Chicago on a map, that would represent a dot on the map. That would be like a point. Okay, all right, a line. Big thing that you have to understand in terms of a line is the symbol. So I'm going to use the idea of XY. Okay, and we do a line above the letters with double arrows. That represents a line. Okay, a line is infinite in length. It goes on forever in both directions. Okay, there's lots of different ways that we can name lines. XY is one name. I can flip the letters around and say YX, and that would be the same name. Okay, at the same time, I'm going to go over here to our picture, and I'm going to add in a lowercase n here. I can name this line using that lowercase n, and I would just call it line n. Okay, so in this case, I would have to use the word line. I can't use the double arrows. All right, and we're going to do some more examples of this as we get going. Okay, all right, next we have a plane. The big thing that you have to understand with a plane is that it always uses 3 letters. Okay, so unless we have an italicized one, which I'll show you in a second. So I would talk about like plane A, B, C. That'd be an example. And another name for it would be plane B, C, A. I can use the same 3 letters and just put them in a different order. Or, like you see in the picture over here, they put in a little italicized letter down in the corner. So that's plane R. Okay, so when I say A, B, C, I'm talking about points. Okay, so like for example, if I were to use the picture over here, I'm going to take this point right here, and let's make that into an A. So name for this yellow plane. So the plane is this. Okay, the plane is the yellow figure that you see. This would be plane XGA, and I could have said AGX, I could have said XAG, I could have said whatever I want. Or I can call it plane R. R is not a point, it's a name for the plane. Okay, so big thing that you have to understand is lines are going to use 2 letters. Whenever we're talking about points, planes always use 3 letters. And we're going to talk later about a theorem in which, or postulate that through any 3 points there exists the plane. All right, big thing that I want you to understand is the difference between the line here and the line segment. Okay, so I'm going to make a big emphasis between these 2. So I'm going to use the same letters. So we said XY with double arrows. A line segment would be XY without the arrows. Okay, and so a line segment has 2 endpoints. Those 2 endpoints are represented by X and Y, and it can be measured. So it does have a length, unlike the line that goes on forever. Okay. Again, another name for this could be YX. It means the same thing. It has the same endpoints, and the measurement would be the same whether you measured it forward and backwards or backwards and forwards. Okay. All right. Continuing on, a ray. Okay, a ray is one arrow. So if I keep with the XY, it would be like this. That would be a ray. Now the first letter represents our vertex or our endpoint. The second letter represents the direction. Okay, so big thing that you have to understand is that the first letter is the end point, okay, or sometimes you might hear it referred to as the vertex, okay, and then the second letter is the direction, whether we're going north, south, east, or west, okay? So I'm starting at X and I'm going in the direction of Y, essentially is our ray. We cannot flip this around like we did with line segments and lines, because that means I would be starting with a different letter and going a different direction. And we'll talk more about that when we get to opposite rays. All right, collinear. You probably learned the prefix co means together, so collinear means points together on the same line. So points on the same line. So let's go back up to our example, okay, that we see up here with the yellow. I would say that N, A, G, and M are collinear because they lie on the same line. They're all on this line. Whereas X is not collinear because it's on a completely different line. It is not on that line. P is not collinear because it is not on that line. So collinear, on the same line. So if collinear means points on the same line, then that means coplanar is points in the same plane. Okay, so if I go to our example with the yellow, and I'm going to throw in a couple extra points like Z, and we'll throw in a B up here, okay? X, Z, A, and B are all coplanar because they lie in the same plane, okay? So they're coplanar. All right, opposite rays. This is an important one to understand. Okay, it's a confusing one. Opposite rays are going to have two stipulations. Number one, they have to have the same endpoint or vertex. That has to be true. Okay? The second thing is together they form a straight line. Okay? So that's the important thing that you have to understand. Okay? And I'm going to throw in a couple of examples down here that you can use in order to compare. Okay? So I'm going to draw this line. I'm going to put two letters on it. I'm going to put M and I'm going to put N. So if I talked about MN, that ray, that would start at M and go this direction. If I were to talk about ray NM, I would start at N and go this direction. So the question is, are they opposite rays? Because they're going opposite directions. And the answer is no, because they do not have the same endpoint. They don't start with the same letter. Okay, so those are not opposite rays. Okay, so now all I'm going to do is add another letter in between. I'm gonna erase this part too. Okay. All right, so I'm gonna add another letter in between. I'm gonna add in the letter L. Okay. So now I've got ray LN and I've got ray LM. So LN goes like this, LM goes like this. So remember, we always start with the first letter, L, and then go in the direction of the second letter. Well, in this case, since number one, we're starting with the same endpoint, and then together, the two rays, it looks like it forms a straight line. Okay, it's fitting both criteria, therefore These two would be considered opposite rays. Okay. Last one, I'll use the same letters, but this time I'm going to do this. I'm going to say M, L, N. Okay, and if I asked is LM and LN opposite rays, you would say no, because even though they start with L, they're not forming a straight line when you put them together. It's kind of bent. Okay, so that's the big thing. It has to fit both of these criteria. All right, last thing that we're going to talk about before we do a couple of examples is intersection. It's simply asking what is formed when two things intersect. Do you get a ray? Do you get a point? Do you get a line? Do you get a plane? What is formed when two things intersect? So for example, if two lines intersected, what is formed? Well, they both overlap at this point. So when two lines intersect, a point is formed. All right? Another example. Let's say I took a plane and then I drew a line and had a line pass through that plane like a sheet of paper. Well, again, a point is formed. Okay? It's just that one hole where that line passes through. Okay, to do something that's not a point, if I had one plane intersect another plane, okay, well, what would essentially happen is they would intersect right here and form a line. All right, so just understand that concept. What is formed when two things intersect? And we'll do some more examples with that in our next lesson. All right. Page 2, examples. We're supposed to use the diagram to provide the following answers. So give two names for PQ. Well, we talked about this on the other side. What you can do is you can, number one, flip the letters. So you can say QP, and this is a line, so it's double arrows. It's hard to see, but there's arrows on that. Or you could say line N, because it's labeled line N. Give two other names for plane R. R is not a point. It's the name of the plane because there's no dot next to it. So I'm looking for three letters in this pink or orangish, peachish region. Okay, so I could say VSP is a name for one of the planes, or I could go VPT. As long as I'm using any three variations of the letter, of those, or any variations of those three letters. All right, name 3 points that are collinear. Concept I'm checking here is give me 3 points on the same line. Well, it looks like S, P, and T are on the same line, so I'm going to go S, P, T. D, name 4 points that are coplanar. I want 4 points in the same plane. That'd be these 4 points, so I'm going to go V, S, P, and T. All right, example 2. This deals with the idea of collinear, and we're going to talk about the idea of algebra at the same time. We're going to try and combine the concepts. So it asks, is 319 collinear or on the same line as y equal to 4x plus 7? So if you recall from last year when we did this, your first number is your x, the second number is your y. So I'm going to plug those numbers in for the letters. So 19 equals 4 times 3 plus 7. If I simplify this, I get 19 equal to 12 plus 7, or 19 equal to 19. Since they do equal each other, that means that this point is on the same line. If it wasn't equal, then they would not be on the same line. All right, last example, example 3. All right, for this one, our objective is to graph this and then see what picture it creates. So if you recall, on a number line, we'll keep it simple. We'll put 7 here in the middle. You need to remember that you use an open circle for greater than and less than, and you use a filled in circle for greater than or equal to, less than or equal to. So since it's greater than or equal to, we're going to fill this in. And then since it's greater than 7, well, 8 is greater than 7, 9 is greater than 7, I'm going to draw my arrow going to the right. All right, so what picture did I just form? Well, to me, this looks like a ray, because I have an endpoint and a line going off in one direction. So there you go. That's our first lesson. If you have questions, bring them to class, and then we will spend a second day with this.